Next example. This one's a little tougher. Okay, what do you think we do here?
You have to multiply them by all those different.
Yeah, I'm going to have to not only multiply by x minus 1, but x plus 2 as well, and 2.
Can you do
Right?
x plus 4?
X plus 4? You could, but it wouldn't help you.
Oh.
It would make things more complicated. One thing we can do, rather than going this guy, and then this guy, and then this guy, we can do them all at once. So we're going to multiply, it'll look a little big, but we're going to multiply everything by this expression, essentially.
Don't forget your non-permissible values.
Yeah, we'll do that in a second. But this is what we call the least common denominator, right? We multiply everything by the, not the drug, LCD, but the least common denominator.
Isn't that LSD?
Oh, right, okay.
Not that I know my drugs.
Okay, but you're right, yeah, non-permissible values,
Liquid crystal display.
x can't be, that's maybe where I got it from. X can't be 1 or negative 2. Okay, so we got to keep that in mind. And we also have to watch out for extraneous roots. So let's do this. It's going to look a little long, but here we go. So x minus 1, x plus 2, and 2 times, you know what, I'm going to do it like this.
You're just going to put it over.
I'm going to put it up with the numerator, because that's essentially where it goes. All over x minus 1.
Whoa.
Okay, so here's the least common denominator, and then the rest of that is just the original fraction. Equals 2 times that huge mess. All over x, whoops, plus 2. And minus 3, I'm going to have to go down, minus 3 times that big mess. Okay? So what happens when I do that? Well, this guy cancels, right? The purpose is to eliminate my denominators. So I was successful that time, as well as this time, and this time.
Didn't we do this before?
We did this in grade 11, yeah. Just trying to help you remember. So that leaves me with 2 times x plus 2, 2x plus 1, equal to 2 times x minus 1, minus 3 times lots of stuff here. Got to be careful, right? So now it's just a matter of distributing and foiling. Am I going too fast?
Oh, I just erased it because I was going to run out of room. So.
Okay, so I'm going to foil this and this. Should I color code it? No, I'll just highlight what I'm going to do. And then this becomes a 4, and it'll distribute into each of these terms. Okay, so I'm going to foil this, distribute 4 here, and foil that. That'll be the next line. Okay, so that's 2.
Why do you foil it and not multiply the 2 in?
You could multiply the 2 in. You would just multiply it into one of these terms, not both of them. It would only so it would make this either 2x plus 4 or this 4x plus 2, but not. It wouldn't change both of them. It would only change one of
And
them.
then you'd have to multiply it.
And then you would have to foil anyways, right?
You know, I have a solution. Instead of playing hockey, let's have a beanie bag toss game.
2x squared x plus 4x is 5x, and 2. 4x minus 4, and x squared plus x minus 2. Okay, so just as a way of a reminder, this foiled to this. The 4 multiplied in here became that, and this foiled to here. Okay, and now to distribute this 2 and this 3, and then we'll simplify.
Wait, how'd you get 5x in the first one?
Because I had x times 1 is x, and then 2 times 2x is 4x, and I add those together to get 5x.
Oh, thanks.
Just trying to,
Speed it up.
yeah, not write so much. 4x squared plus 10x plus 4. 3x squared minus 3x plus 6. Wow.
What did you do there?
So I multiplied this 2.
Oh, you multiplied it in?
Yeah, I multiplied the 2 into each of these terms, and then the 3 into each of these terms. Welcome to math. Are you following?
Yes.
Yeah, you guess? It's a bit tedious, right? But you just got to be careful at each step. Right?
And then we're going to bring everything over.
And then,
to
yeah,
one side.
now we're going to bring everything over to one side. Right? So I'm going to bring everything to, it doesn't really matter.
I brought the left over.
I'll bring it to the left. So, the 4x squared and this negative 3x squared become positive 7 when I bring it over. The 10x and then minus 4x plus 3x is 6 plus 3 is 9. And then the 4 plus 4 is 8 minus 6 is 2. Follow? Did I skip too many steps?
I was just not paying attention when we were doing stuff.
You guys good?
Okay, go back to the 10x
So the 10x,
plus
10, if I brought the 4 over, that'd be 10 minus 4.
so it's 3x, right?
6, right? So it's 10 minus 4. That'd be 6. And then bring over the 3. Be 6 plus 3 is 9. Does that make sense? You would have 10x minus 4x plus 3x.
Okay, that makes sense.
And then that makes 9. Right?
When we multiplied the negative 3 and I forgot to change the x to a negative.
Yeah. Okay. And then the same thing with the constants. You had 4 here, right? So you had 4, and then plus 4 was this guy, and then minus 6 is this guy, and that gives you a net result of 2. So that's where that comes from. Okay. Good? And then we got a bunch of options here. We can do magic number, or we can do quadratic formula. Let's do quadratic formula, just because it's a little more universal. So negative 9 plus or minus.
You do it with the
What's that?
magic number thing.
You could do magic number, yeah. 4AC.
81.
Yeah, 9 squared.
Alright.
So 28 times 2 is 56. What does that equal? 81 minus 56 is 30. 31 minus 6 is 25, yeah. Ugh, thank you. Which is plus or minus 5 over 14. Okay, so that either equals negative 9 plus 5 over 14, which is, how much is that? It'd be negative 4 over 14, which is negative 2 over 7. Or we could have, negative 14 over 14. So negative 1. Did you get that? Yeah? Nice. You guys are ahead of me.
I just a magic number.
Okay, that's fine. So here are our solutions, and I'll just pause there for a moment. Give you a second. Did it make sense? I know it's a lot of steps, but like I said, you guys should know all the algebra by now. It's just cramming it all together into one nice equation. Right, so check it against non-permissible values, negative 2 over 7 and negative 1. So are we good? Okay, so that checks out. We also have to put them into the equation to check for extraneous roots. Right? Because we could have created an equation in our calculations. So put negative 2 over 7 and negative 1 into our original equation. Tell me if it balances out. This one works. Good. Thank you. And what about negative 1? Anything?
Yeah.
You checked it? Okay, good. So this one works as well. Nice.